Right, good evening. So we have been studying about SDLC, System Development Lifecycle. In the previous class, we started the first phase. I took some time to explain the first phase because we have some methods for gathering the requirements. So every method needs to be understood. So I took some time for explaining. Right, so let's take a quick recall. So what is SDLC? It's a method, or it's a set of process needed for developing a computer-based information system. Okay, a computer-based information system cannot be developed overnight. It takes time. It needs multiple activities. So this SDLC is a collection of all these activities needed for developing a computer-based information system. SDLC has 6 phases, 6 steps, right? Every step has to be carried out one after the other. We started the first phase, that is identification of requirements. The second phase would be designing the solution. Third, coding the solution. Fourth, testing and debugging. Fifth, deployment. And finally, maintenance, right? So let's take the first one, identification of requirements. Look, so as we discussed previously, here the needs or the problems should be identified because at the moment you may have a system, it may have so many defects, it may have so many issues. So you have to carefully identify them because these problems or these defects cannot be in your new system. So you need to identify those problems. And also you may identify some of the new things or new requirements to be added to the system. Have you understood? Maybe the problem which are in existing system or some of the new requirements. Anything is okay. But identifying the problem is very tough because not all the problems or not all the requirements are visible. So you have to use some of the ideas or methods for identifying the requirements. So we have different methods. I explained many of them, right? I think I explained 4 or 5. Let's take one more, right? So we discussed about observation. Okay, so it is about observing the activities of the current system. You can observe the things, right? Or you can observe the progress of current system and take some requirements. Then interview. Okay, so it's a face-to-face method where the questions are asked by the interviewer to get some requirements, right? I explained about interview and also questionnaire. So it's a printed material where you have questions as a bunch. So these questionnaires will be randomly issued to the users to get the feedback. So once feedbacks are taken, they have to be analyzed, right? We have to analyze each and every question and get some conclusion, meaningful conclusion, right? So then we have group discussion. Right, this is another method, group discussion. So this is different than the interview because in interview, both the interviewer and interviewee engaging in communication, right? There are no other people. But here in group discussion, it must be a panel, right? It must be a panel discussion where multiple people engage, right? So it may be healthy because people from different group participate there. So it is sometimes it is worthy because you cannot hide anything, you cannot hide any negative sides. So you have to openly discuss. So it may be very meaningful and very perfect to get the requirements which you exactly need, right? So group discussion. Then inspecting the documents. I explain all these things, right? If I didn't explain any of them, try to remind me, because I thought that all these requirements, sorry, all these methods were already explained. Now I'm recalling the things. I explain all these things, right? What about inspecting the document? Did I explain for both batches? Inspecting the document, did I explain for both batches?
No, sir.
What about group discussion? Yes, right? No?
Yes. Yes, sir.
Okay, right. Inspecting the documents or checking the documents, that is also another method for identifying the requirements. It's a very simple term, right? You can understand, because see, as a system, you have some documents presently, because hope you remember the 3 instances where we use SDLC, right? So you may have an old system which is manual. You try to convert that into computer based. You may have a computer system, sorry, you may have a system which is in computer format. Now you want to turn that into another CBIS. Or the third instance, you are developing a CBIS directly. So whatever the case is, you can take this document. So if you assume that you have an existing system now. So in that particular existing system, you may use some documents, right? So okay, take a look at the manual system. Assume best method is manual. See, assume that you are running a manual information system. In this manual information system, you use some documents in order to perform your routine activities. So these documents are vital for the new system, because when you analyze the document, we can get some conclusion. We know we can study the system, because as a developer, that person should understand the system. That person should understand how the system is being progressed now, right? So it is important to check the document. For example, if I take one example, say, okay, take the library. If it is library system, currently, assume this is manual now, right? That library system is in manual now. So currently they may use some manual documents. So they may use some registers for, storing the book names and other book details. And some other manual materials are used in library. We don't know exactly, right? But definitely. So those documents must be inspected, because when we inspect those documents, we can get some meaningful requirements. Okay. So I think I explained this example for the other batch. See, assume that you want to develop a report book in a producing system, right? So in your school, progress report is generated by a computer-based system. So a particular school wants to develop a system for progress report, computer-based system. So that school may use this method, right? Document checking for checking your current report. You know, now you have a report book which is in manual printed report book. So as a developer, we can analyze that particular current report, the manual report. So by looking at that manual report, I mean that present report, we can get some requirements. And in fact, we can understand the system. So I know that, okay, students' marks are there, their highest marks are registered, total registered, and average found, rank calculated. So these are some of the requirements for us. Okay, so that is inspecting or checking the document. Finally, prototyping. Prototype. See, observation, interview, questionnaire, group discussion, documents. They are too simple. Simple means maybe conducting them and preparing them may not be hard. You know these things, right? Observation, you can observe the things. Interview, so go and ask questions directly, right? So questionnaire also, it's not big thing, right? You have to prepare the questions, right, and print them. a group discussion, document checking. But this seems to be little tough because prototype means as a developer, you need to develop a sample of the new system at the initial stage. I repeat it. So you are about to develop a system, right? So it takes time, maybe months, maybe years. But since it's even though it's an initial stage, as a developer, we have to develop a sample system with limited features and given to the users for use. But remember, we are in the very first stage. But even we are in the very first stage, a sample is developed and it is submitted to the user to get the feedback. But don't think that it is a complete system. Don't think that that is a system borrowed by another one or something. This is developed for you, but with limited feature. For an example, if it is a report book system, right? So assume you requested me to develop a progress report generating system. So since I know about progressive report, I can produce, so I can develop a simple system with limited feature. You cannot expect all the features there. Maybe some, right? Marks can be entered, maybe total can be found, or some features are there. With limited features, I developed the report system at the initial stage and given to you. Now, you are able to see the system at the initial stage. Even though it is a limited system, you can see that. So when you see the system at the beginning, you know, it's very good because in all the other instances, you can see the system maybe after some months or maybe after some years, maybe at the end of the system development only you can see that. So sometimes when you see the system after 6 months or after 1 year, you may be disappointed because sometimes that may not be the system that you wanted. Have you understood? The requirements are taken from you, but sometimes you may have some imagination, so you may have some different idea in your mind, but the output will be totally different than what you expected. But here, if it is prototype, you see the system at the very initial stage. It may be okay, right? You may have limited feature, but you have the idea, right? You know what is your final product is, right? So that is called prototype. So that sample of the system is developed and given to you. Assume that you are the users, right? Given to you for getting feedback. So now you may suggest so many things. You may ask some new features. You may request me to remove some of the features. So now after getting all these feedbacks, I can further develop that particular sample. That is called prototype. So now imagine, definitely it takes time, right? Because I have to spend some time at the initial stage for creating or developing that sample. But here, they are different. Have you understood? So this is called prototype. So what is it? So prototype is a sample of the particular system with limited features. That can't be the final product, but it looks like your final product with limited features. Okay, so you may have different methods for taking or gathering requirements, right? I might have mentioned the person who is responsible for collecting all these requirements. So during this first phase, there is a person called system analyst who is very busy with, capturing all these requirements, right? He is the responsible person for performing all this, right? Conducting interviews, maybe preparing the questionnaires, everything, right? So don't forget system analyst. So who is it? He is the person who gets the requirements, and once the requirements are gathered, he has to prepare a document called system proposal. System proposal. This document is very vital because all the requirements are carefully documented. Maybe the time duration from which date to which date the system development should be continued, or what are the people engaged in activity, or who are the people engaged in activities. So all these things must be documented in this particular material called system proposal. So this system analyst has the responsibility to prepare that system proposal. So once the system proposal is created or is prepared, it has to be handed over to the particular institution for getting the approval. So assume you belong to the library, you requested me to develop a system. I am the software development company. So I have sent the system analyst to your premises for gathering the requirements and everything. Now he came back and prepared the document, which means prepared that system proposal. Now the system proposal has to be handed over to your school administration. Why? For getting the approval. Because you have to carefully check whether all of your requirements are documented, whether as a developer I understand what you meant, because sometimes, you know, it's all about people conversation. So sometimes you may have an idea and based on the idea you give the requirement, but I may understand that one in a different manner and get some different idea. So that doesn't work, right? So you have to check everything. If you think that all the requirements are included in the system proposal, then you can give the approval. But if you feel that some of your requirements are not included in the requirement, in the system proposal, or some of the requirements are misunderstood or something, then you can request me to change the system proposal, making some adjustment. So I have to adjust. So after adjusting or after changing or after modifying, I may give the system proposal again to you to get the approval. So once you approve, then the SDLC moves to the second phase. Have you understood? So this is called identifying the requirements. Right. So look, now the requirements are carefully identified. Okay, the system proposal also approved. So it's time to start working, right? So now maybe we started, the SDLC started activities related to new system, right? But maybe that is not the actual work, right? Maybe you do some logical things, or you do some activities which are prior to the system development, right? Those are requirement gatherings, right? So after getting the requirements, we have to take the second phase, that is called designing the solution. You may take that as designing the solution, or design the solution, or designing the solution. It's not a matter, right? Look. So as the name implies, you have to do some designing activities here. So designing the solution, even you can take that as designing the solution. Designing the system. Here, designing the solution means we are going to design the system. That may be the indirect meaning, right? Look. So this is very, very important phase, because, you know, for developing anything, designing is very crucial. Say, if you want to build a house, you must design it carefully. So whatever, I assume that you want to manufacture a tool, or maybe a motor vehicle, or maybe ride bicycle or something. So design is very important, because your final product should be manufactured or should be developed based on the design. If design goes wrong, definitely your system fails, right? So you have to spend a lot of time for designing, and more importantly, you need to design it carefully, right? Look here. In this phase, we have to perform some of the activities related to design. I tell you one by one, but before that, I have to remind one thing. Look, we are developing, right? We are developing a computer-based information system, right? We are developing a computer-based information system. So in computer-based information system, we have multiple components. We already discussed, right? So hope you remember the components used in CBIS. We have hardware, we have software, we have databases, we have communication, telecommunication. So a computer-based information system has plenty of components. So in this particular phase, those components need to be decided, or those components need to be designed. Look here, I take one by one. If it is a computer-based information system, definitely there is a software needed, because you may use the hardware like monitor or system unit or whatever, but yes, having the hardware is important. At the same time, in order to perform tasks in the system, you need a special software. You may take any computer-based information system as an example. Say, you know about banks. You know, banks are computerized. So they are computer-based information system. Look how a bank performs those day-to-day activities. Is it because of the hardware components like printer, scanner, monitor? Maybe okay, but more importantly, having them is important. But in addition to them, you need a software which can perform the tasks. That software cannot be purchased, right? You have to design that specifically. So here also, right, in this particular phase, you have to do some of the designing activities for your software. I tell you some of them. Look here, you want to develop a software. So definitely, before developing the software, you need to identify the components which are available in your software. I repeat it. You have to develop a software to perform the activities in your system. So, you know, software is not a single component. It's a collection of multiple components. So during this phase, you have to identify each and every component needed to be included in your system. For example, if I take a simple example, look here. So assume your school wants to develop a school management system for managing all the school activities. I take another example, right? I just move from your library example to another one because I feel that it is easy. Your school wants to develop a new system which is called school management system, SMS or something. That is for managing all the activities, right? Students' activities, teachers, right? Maybe accounting activities, all of them. So now, you know, it's not a small system, it's a big system because it must have all the features, right? So now, I mentioned that software components must be identified. Okay, so now imagine your system is big. It may have so many features. Now we can find some of the components. See, there may be a component for marking students' attendance. There may be a fingerprint or maybe a facial recognition or maybe a card reader to take the student attendance. So that part is available in that particular system. And also, you know, at the end of the term, report book is given. So report book has to be produced, has to be generated. So that same system may have another component for producing the report. That is another component. Maybe account activities, account works. You know, school often deal with money. So there should be accounting works. So to perform accounting activities, that system has another component. Have you understood? Like that. So your school has so many, goods, right? Electronic goods, right? Some other furnitures, and there are so many goods, right? Things. All these things must be registered, right? So your system may have another feature for getting these things. We call them as inventory details. Inventory means your the things which are in stock. It may be computers, it may be books, it may be science equipments. That is another one. So imagine, as a developer, you need to identify these components first. It doesn't mean that you develop them straight away. You just want to identify them. You have to plan them. Okay, we are going to develop a school management system. Okay, so better include attendance system, better include mark system, right? Better include inventory system, maybe library system. So that is the first one. Okay, identifying the requirements. If you have any doubt, you can ask, right? So designing the solution phase has many designing activities. The first one is called identifying the software components. You may find these software components in every system, right? Even in your library system also there may be components, but the number of components may differ from system to system. But since school management system is big, we have multiple components, right? Look, after identifying these software components, you need to do one important thing. Look, I'm sticking with the same example, right? School management system. Now I have identified all the components need to be included in my system, like I mentioned earlier, right? Your inventory, student attendance, everything. After identifying the software components, I have to check whether these components have any relationship, because sometimes, you know, some components may have some sort of relationship. You have to join them in order to get the output. For example, say you have scholarship funding system, or there scholarship fund or something in the school management system. There is a small component allocated for your grade 5 scholarship fee or something. And also the same school management system has attendance. You know, attendance and the scholarship payment may have relationship, because students who attendance sometimes get paid less. So it is calculated, I think, based on the attendance or something. So you already identify the software components. After identifying the software component, you have to look for any relationship. So if you think that some of the components are related, so you have to arrange like a group. So this is called software architecture, right? You have to get some sort of links in between the components. You have to find the relationship between this component. This is called software architecture, right? Software architecture. This is another important task taken place here. Have you understood, right? Understand everything, never ever memorize. That's why I'm taking some time, right? So this software architecture very important, because you know, at the time when we develop those components separately. We develop the report book as a separate component. We generate that attendance system as a separate one. So right, that happens as a reality, right? You have to develop them separately, but you need to think about any relationship. That is called software architecture. Okay, so these two are related to software. Identifying the software components. After that, you have to identify you have to create the software architecture. Then I already told you that hardwares are very important, because your software will run on top of hardware. So you have to decide your hardware components. When it comes to software, you are the responsible people to develop. You cannot buy them from the shop, because you know, your requirements are unique. Your requirements are specific. Others cannot guess them, I mean, as a comment. So that may be the reason why you give the requirements and develop the system. But when it comes to hardware, you cannot manufacture. So hardwares need to be purchased. But even though it has to be purchased, you have to decide the hardware component. What does it mean? You have to decide the processor speed. That is important, right? Because sometimes if your program is heavy, you need some fast CPU, fast processor. You cannot use your home computer for banks or some other institution because you are running a software, right, with multiple features. So you have to decide, okay, which processor is applicable. What about the speed, which 3 gigahertz or 3.5 gigahertz? So you have to decide. And also, you know, random access memory is important. So you have to think about RAM. What about the capacity of RAM? Is 8 GB enough or 16 GB needed? Decide it. And also you can think about your, hard disk capacity, because you have to save everything in the hard disk. So decide it, whether it is 1 TB or 2 TB. That is another one. Even you can decide your monitor size. If you think that you need a big monitor, try deciding. So sometimes if you think that small monitor is enough to see the things, decide it. So these are called identifying the hardware components, right? Identify the hardware components. Because after identifying the hardware component, then only you can purchase. Okay, I tell you again, these are not to be manufactured. You cannot manufacture, but you have to, you have to buy them. So before buying them, try to decide the hardware. We call them as specification. Specification means hardware characteristics, speed, capacity, everything. Okay, this is another one. Look, in manual information system, you can keep the data in papers and files and in any other manual material. But here we are developing a computer-based information system. In a computer-based information system, everything, every data needs to be saved in databases. In fact, in electronic databases. So here you need to develop your database. That is another one, designing the database. Okay. Designing the databases. If it is designing the database for a student who learn in grade 11, that term is enough. Designing the database design. But we already studied databases in grade 10, so we have some idea, right? So can anyone tell me some activities which can be included in database designing? Tell me one or two activities. See, database designing is a common term. Designing the database. So you should know how a database is designed. You should know what are the background activities taking place. Tell me one or two activities which are related to database design.
Identifying the software for the database.
Identifying the software. Okay, what else? Any others? Have you understood my question? If it is designing the database is a common term. So now, since you learned about database in grade 10, I'm asking you some question, right? So tell me one or two activities which are related to database designing. What does this term include? Is it not hard to guess? Any others? No? Look. So, you know, database is a collection of tables. You already learned, right? In grade 10, unit number 9, we learned. So here the database design means, as a developer, you have to identify the tables need to be developed or need to be created. So if it is school management system, you have to decide, okay, let's create a table for students. Let's create a table for storing the payment details. Create another table for storing books details in the library. So another table for showing borrowing details. Another table for storing the inventory details. So these are tables. You know, these are related to database. So you have to decide that. So once you decide a table, then you have to check, okay, what are the fields available? If it is student, what about fields? Okay, admission number, name, date of birth. If it is payment, okay, what are the fields to be added? So do it. So this is also database design. After deciding these tables with fields, then you have to check the relationship. So if you have two tables, so then you have to check whether it is one-to-one relationship or one-to-many. All these activities are included in this term database design. I just put it as short, right? Database design, but includes many things. What are they? Identify the tables along with the field names, and also creating relationships or deciding relationship between table. Everything is designing the database. Okay. Then number 5. Look, in the first two, these first 2 points are related to software. In the first phase, we identify the software components, and after that, we created the software architecture. That's why these are related to software. Look, a software must have interfaces. In grade 10, we learned, right? You may take any software, it's all about interfaces, because these softwares must be handled by the users. So how can a user interact with the software? Definitely there must be interfaces. Those interfaces must be designed at this particular phase. Okay, so if it is, assume, take a simple interface. So assume that in a school management system, a user has to be logged in, right? Because if there is no login feature, it is insecure, anyone can log in. So assume that you have to develop a login page. That may be the first page, right? Login page. So now you have to decide, okay, what about the background color? What are the terms to be added, or what about the heading with the user login or any other names? And then you can decide what about the box size. You have to give a text box, right, for typing the username and password. So decide what about the box. Is it, wide or maybe small? And what about the shape, whether it is a 3D box, so whether a flat box. So decide everything. This is called interface design. You don't need to design in computer, just it's a paper-based design, right? It can be a paper-based design, but you need to carefully design the interface, because the success of a system may depend on the interface too. Because as a people, we want attractive and user-friendly interfaces. See, if an interface is not attractive, as a human being, we are not interested. That's the nature of us. And also, if an interface is tough to handle, we never get interested. So you must carefully design those interfaces, making sure that it is user friendly and it is attractive. That is also there here. Designing the user interfaces. These 5 activities are very important during this phase. There may be more than 5. I think your book has more than this, but these are very important. But remembering or understanding these 6 activities is not hard. Before remembering these things, try understanding a computer-based information system has so many components like hardware, software, databases, like that. So if you have that idea, then you can easily understand. I repeat them. In designing the solution phase, you have to perform some of the activities related to designing. The first one, we have to identify the software component, because in CBIS, there should be software developed. So if it is a software, it must have multiple components, right? Multiple features. So they must be identified. Once the software components are identified, then you have to create the architecture, which means you have to check whether there are relationships between components. So if some of the components have relationship, then you have to categorize them as a group or something. So that is software architecture. After that, you may create the interfaces, right? You may design the interfaces. So there may be number of interfaces needed. So you have to design them in this phase. Yes, you need a database for storing the data. You have to design the database, which means you have to decide the tables along with the fields, and also you have to take the relationship. And you also need to decide the hardware components, maybe major hardware components such as processor, random access memory, maybe hard disk, and some of the less important hardware components like monitor size. Maybe sometimes even you may check the number of ports that you need. You know ports, right? USB port, how many USB ports that you need? Do you need a VGA port? Or what about HDMI, ICT? Check it. You have to decide them. That is also identifying the hardware. Okay. So these are taken place in second phase. Okay, so if the design is perfect, then SDLC moves to the next phase, because here now you got some idea, right? If the design goes wrong, your system will definitely fail. You design the database, you identify the software components, assume that you forget to identify one important component. What happens? You maybe in the next phase you will develop the system without that particular component. So how can it be it become as successful? Definitely it fails. So here you develop that, or you design the database with some sort of issues, or you missed a table, or you misunderstood the relationship. So definitely it fails. So you have to spend the time, a lot of time for designing. Okay, right. Then next one. Any questions? Right, look. So second phase is over. What is it? Designing the solution, which means designing the system. So we did some designing activities now. So once the designing is over, you can start the coding. So next phase would be coding the solution. Okay, coding the solution. Look, as we know, software is a set of instructions. Right? We learned them in grade 10. Software is a set of instructions. Now, don't forget, even though we mentioned that we are developing a system, it means we are developing a software. Don't forget it. Right? So students often confuse. Look, the heading is System Development Life Cycle, which means we are developing a computer-based system. But think about a computer-based system. Okay, if it is a computer-based system, the major component is actually software. So system development life cycle means software development life cycle. Even you can see such phrases in books. Software development life cycle, system development life cycle, same. Because in this particular computer-based system, software is the vital component. The others can be purchased, right? Hardware or whatever you can purchase, but software is very vital. So now, in this particular phase, you have to write instruction for develop the software. So how can we define the term software? Set of instructions given to computer to perform tasks. We learned that in grade 10, right? So software is set of instruction. So now time to develop the software, right? Time to develop the software which we need. So how to develop? We have to sit down and write the instructions. But you know, you cannot write the instructions in human languages such as English or Sinhala or Tamil or whatever, because computers cannot understand human languages. So you have to select computer programming languages for writing the instructions. Look, the computer programming languages are the languages which can be understood by the computer. So there are hundreds of computer programming languages out there. So as a developer, you have to pick the right language, appropriate language for your purpose. So select a computer programming language and start write the instructions. This is enough for in terms of theory, right? We can take such things for our understanding, but in a practical scenario, it takes time, because writing the instruction for creating this or developing this software definitely needs time. You have to spend maybe months, right? Many months for completing your writing activity. So I mentioned about programming languages. You might have heard, right? So you have so many programming languages. You have Java, you have C, you have C++. Even in our syllabus, we have Pascal, right? Pascal. We have Python. So there are hundreds of programming languages available. Select one of the appropriate programming language and start writing the instruction to computer. This is called coding. Coding is nothing, giving instructions, right? Code means instruction. So you have to write the instruction to computer to perform tasks. That is called coding the solution. So who is responsible for writing this coding? This is called programmer, right? The person who is responsible for writing those instructions to computer is known as programmer. So now programmer has to write everything. As I mentioned, it takes definitely time. So he has to be there patiently for writing the instruction. Okay, so once the instructions are written, then the software is ready, because software is nothing, set of instructions. If instructions are given to the computer completely, then it means the software is ready. Okay, so this is called coding the solution. So I take the things which need to be remembered about coding the solution. First of all, remember code means instruction. So instructions need to be given to the computer, because software is a set of instructions. We are developing a software. So we have to give the instruction to computer. But unfortunately, computers don't understand any human languages. Computers can understand computer programming languages. So we have to select a computer programming language and start writing the instructions. This is known as coding the solution. Computer programmer is the responsible person for writing the coding. That's enough, more than enough. Okay, so once the coding the solution phase is over, I can say that the system is completely developed, or system is developed, because you already designed the databases and everything. So now you spend time in writing the coding. So once the the instructions are written, it means the software is ready. But you may wonder how or why we have 3 more phases. You have 6 phases, but now we just completed 3 phases. But even though we completed 3 phases, I just mentioned that the system is almost ready, right? It is developed. So don't think that the remaining phases are useless or something, but they are very important, but they will have some different tasks. Okay, right. Now, at the end of this coding the solution, your system is ready. But, even though the system is ready, you cannot use the system. You cannot start using your system, because that system may have errors, because that computer-based system was developed by people. So even though they took time, even though they took, they analyze every data carefully, there is a possibility for making mistakes. So what happens if you start using the new system directly, then you will have to face a lot of challenges. So suppose if you are using the new system, sometimes suddenly it fails. So if it fails suddenly, you cannot do anything, because you depend on the computer system. So before start using, you have to test for errors. That is called testing and debugging, right? You have to test for errors, and once errors are found, you have to correct them. So in English, bug means the errors which you made in programming, right? Bug. Debug means identifying the bug and correcting that. That is debug. So testing and debugging, which means we have to test our system for errors, and if errors are found, we have to correct them. This happens in the fourth phase. But I just briefly explain the main function of testing and debugging. But testing has different types. You have to spend a lot of time for testing. Right, so I will mention the types of testing later, but before that, I take one example. Look, assume you design the system now. Okay, let's say progress report. I develop the progress report, but before start using the progress report, I want to test because I have doubt. I have doubt on it, so I think that it may have some errors sometimes while entering the marks or while producing the rank or some other things. I may feel that there may be errors. So before start using the progress report, I have to test. Can anyone tell me how can I test or how to test this progress report? Tell me the method. How can we test this progress report? Anybody tell me, give an idea. I have now the progress report is given to you. It's a computer system, right? You just open in your computer. Now I have some doubt on it, right? I may think that it has some errors. Tell me how to check, how to test it. It's a very simple question. How to test, give you idea. Nobody knows? Look, so assume I have manufactured a bicycle and I gave it to you. So I asked you to test that because I have some doubt whether it runs or not, right? Whether it rides or not. So how can you test that? You want to test that bicycle. How do you test that?
We may take a ride on it.
Okay, you can ride and test it. You can ride, yes, simply you can ride and test it. So when you ride, if it rides smoothly, if it rides as you expected, then you can say, okay, it's fine, it's good. So riding means, so you check whether the bicycle rides as you expected. Have you understood? Before you ride, you have a mindset. What is it? You thought that if it is a bicycle, it should ride. So now you try to ride, it rides. So now you immediately realize that, okay, this is what I wanted. So now it is a progress report. I'm going to wind up quickly, right? So it's a progress report. I have doubt. So how can I test? I can give some marks as inputs, right? And check the output with my expected output. Have you understood? So I have to give some marks, right? Not only for one student, I may take 50 or 60 students, or maybe 10 students, and try to give all of their marks and try to check their ranks. So when I give, I have some expected output, right? I know it's the first rank, second rank. So if my expected output and also that system output same, then I know that the system is fine. Like the bicycle. So before you ride, I thought that it should ride smoothly. That is my expected output. So once the bicycle is ridden, I get the same idea, right? So then I decided, okay, it's fine. The testing is fine. The bicycle is riding, right? So similarly, if I want to test a system for errors, I have to give appropriate input to the system and comparing the expected output with the system output. Expected output, system output. Expected output means as soon as I gave the input, I have some expectation. That never be wrong, right? That must be true. So that expected output should match to the system output. System output means outputs that you obtain from the system. If both match, then definitely you can decide the system is perfect. Okay, so there are types of testing, but I will take them later, not today, right? Enough for today. We will meet in another class. Thank you.